This week we're going to be looking at the nature of spatial data in R. So I'm here in the learning module exploring data. And one of the first things you'll note, there's some information here on the different tools in R, and I'm going to go into there in a second. But first we need some data. So I've got some up here. Now you can use whatever data set you want. I actually recommend using project data if you want. Otherwise you can grab one of these data sets. Note that the data needs to be set up with columns and a header row describing the columns, and then columns of data. You definitely want to have a response variable and some potential covariates or independent variables. As we do all the time, I'm going to go to my desktop, set up a folder for GSP 570. Should have already had one, because we're now on lab 3. Okay, and just gonna save my Doug Fir data for California. And now I'm gonna go into these R tutorials in the R for Spatial Stats websites. Okay, I guess before I leave that, I should go ahead and say that if you don't have data that matches the type of analysis you want to do, in other words, if we're looking at histogramming or scattergramming, go ahead and hit up this page to convert layers. And this talks about how to get your data to be the kind of layer that we need. In other words, if you've got occurrence data, how to convert that to presence absence, or a density layer so that you have a continuous variable. And this diagram shows you that we can map between those. We'll talk about this a little bit in discussions. And then this actually shows you how to do the conversions, either in ArcGIS or for Blue Spray. Cool. And we'll talk a little bit more about that. But for right now, let's dive into the R for Spatial Stats websites with some histogramming. Okay, so if we go down to the histogram section, one of the things you're going to see is there's a number of tutorials there. There isn't a lot of content. I only add content where I feel it's needed. There's huge resources out there for R on the web. Some of them are really good, some not so much. Like this one shows you some cool stuff on how to change colors for the charts if you want to do that. This is one that shows you not only how to do histograms, which is actually really easy. Like for this example, I'm going to just grab this piece of code with a normal distribution, go over to R, whoops, I was working on some other stuff, paste that in. So the first thing they're having us doing is create a random normal distribution with 1,000 points. There's our mean and standard deviation we've done before. Well, the reason I'm doing this is to show you this symbology. That's saying run this function, whoops, and take the result of this function and move it into a variable called BMI. And that's what we can see happened over here. I'll go ahead and sweep that and just show you that again. Okay, so there's our BMR with our random distribution. Now, that is identical to an equals. I use equals because I just asked the students once, do they prefer equals or this? Whoops, that guy. And they preferred equals, and I think I do too now. You will also see this, which I think is really strange and awkward, and I don't recommend that at all. All right, so you'll see me use equals almost all the time, but beware on the web, you'll see the less than dash symbology, and you'll see some other interesting symbology. Okay, so to run a histogram, it can't get a lot simpler than just saying histogram. Boom, there it is. Now, one of the reasons I reference this page is because this page shows you how to change the bin size. So in other words, if we want to do different numbers of bins or breaks to get more detail out of our histogram, here's what we do. And there's another reason I show you this, because it's like, wait, there's an error. Not all the websites you're going to go to are going to give you good information, okay? Take a look at these double quotes. R, what are you doing? Okay. So, better. What happened is, if you look at especially these double quotes, they're slanted. Well, that's a special ASCII character that gives you double quotes that are an angle. Well, we don't want that. That's not recognized by R, and then our studio tries to help us to replace it with something else, and we've got to get rid of those. Now you can see that our string is green, which is it should be. And now we can do that, and we can see we can change the number of breaks without getting an error. Yay! So when you're copying stuff back and forth from the web, be ready for those kind of errors. But this gives us pretty much everything we need in histogramming. And in my opinion, R is actually much easier to do histograms in than it is in Excel. Okay, so that's histograms. Oh, and then there's Quick R. There's quite a bit of documentation in Quick R for how to do things. Not everything like bin size for histograms, so I think it was important to look at that other one. And this is kind of what's going to happen. You're going to have these different websites you go to. Quick R is a really good one. It's got a lot of good stuff in it. I recommend it, but there's a lot of them out there, and you're going to have to kind of figure out which ones work for you. I'll keep throwing up more and more resources for you, and you'll send me some, and I'll add them to the website. Also, this is the formal documentation for histograms. This is what I call the most consistently cryptic documentation I've ever seen. This is the standard format for documentation in R. Let's just walk away from that for now. By the end of the class, you'll be able to read that. For right now, I'd avoid it because yuck. There's lots of other websites out there that have tutorials on how to get through R without looking too much at the standard documentation. Okay, so if we want to do more stuff with looking at our models, we need to be able to work with what's called data tables or data frames in R. Okay, for the rest of this, you're going to want to have a data set that has some response variables and some independent variables in it. You can download one of these data sets. We've got Redwood, Doug fir extracted from the FIA database, and actually there's a zip file here with a bunch of different trees. Go ahead and bring those into ArcGIS or Blue Spray, and then use extract value to pull in values from predictor layers, whatever predictor layers you like, or if I actually recommend use data you might be using for your project for this and start pulling in covariates, predictors, independent variables, sorry for the terminology, that you'll be using in your project. So here you can see that I've got annual height of Doug fir trees as well as the X and the Y, and then annual precipitation, min temp, max temp. These are from BioClimb. I threw in an elevation layer there. And then mean temp, isothermality, which is change, and then present or absent. So ones and zeros for presence and absence. Now this is a pretty big data set. I'm going to give it a try, but we may have some issues with it just because of the size of the data. So we'll see how this goes. Now, what we want to do is go ahead and load this data into R. So now I'm going to go back to the R for Spatial Stats website, go here, Spatial Data's data frames, and you can see how to read a CSV as a data frame directly into R. Okay, so let's go ahead and try that. Whoops, yes, I already did it before. Okay, so to do that, we need to get the path to our file. We can do that by going to our file, and then, is that the right one? Okay, I had some little problems with Excel locking up on me. It seems to be doing that more and more with Google Drive. I don't know why, but I'm going to let it go. I just copied this file over from the web. If necessary, you can go to Task Manager, right-click on the taskbar, pick Task Manager, and kill Excel. I have to do that periodically. All right, so what we want to do is we want to shift-click on our file, copy as path, and then we can go into our studio, and we can paste that path in as the full path to our file. However, notice that we have backslashes instead of forward slashes. We need to convert these to forward slashes or it will not work. And there we go. And now we can run that. I'm going to clean up, do a run, and there's our data, 5,000 observations of 10 variables. Now, going back to the website again, you'll see that we also need to do this NA omit. Now that will delete any lines that have null values in them because R does not like those. Okay, so you definitely want to do that for each data frame. Now we can go ahead and we can simply plot some of these as scattergrams. So in this case, I'm just going to plot x against y. Hey, look, it's California, which is just kind of fun, right? But you can do something more useful. We can click on the data. It will display here. So it looks like I've got height and minimum temperature. Let's see what happens with that. So your first value is your x value, so that would be our height. And my next value would be my min temp. Okay, if we go ahead and run that, what do we see? Well, we don't see a very strong relationship there. Not so much, okay? What about annual precipitation? And notice R will help us a little bit once it figures out what we're doing. Oh, a little better, right? We're seeing a bit of a trend, but we're also seeing a bunch of zeros over here that we're gonna have to do something about. Okay, so quick introduction to scattergrams. But what I really want to show you is now we are going to get into correlations and covariance. So testing for covariance. Here we've got some linear relationships. Well, here I should show you just two random distributions. Both of them drawn from our norm. Different means, they don't have to be different, they can be. And if we run this and then print our correlation statistic, we see that these are not very related because that value is very close to 0. However, if we do some linear models, like here where we've got this equation that's computed off the x values with a 1, and then another one with x times, now that's minus 10. I'm going to convert that to 10 for a second. Do you think that would be correlated or not? Sure enough, perfect correlation. So in other words, we don't have to have the same value. This doesn't have to be a 1. 1 would also be perfectly correlated, but it can be 2, 10, 1,000. The scale doesn't matter. The range of the values doesn't matter. The scale doesn't matter. It's whether or not that they're changing together. And of course, because these are all multiplied times the same x values, these are. We can even put in a negative, and now we're going to get a negative perfect correlation. So that's really what we're looking for, right? And of course, if we plot this data, the labels are no longer correct, but let's just show you what's happening here. We plot these two, you can see that they are perfectly negatively correlated, okay? So, all right. Now, what we really want to test is for covariance in our data between our covariates or independent functions, independent variables. Okay, now this kind of interesting looking piece of code is actually from a student who took the class previously. And note that when I run this one, it says function. It actually adds a function here. Now we've got data up here. We've got values that we've had the whole time. And then we've got functions. So you can write your own functions and add them into your R. And now we can go ahead and run that function, and it will create one of those grids of correlation values. But it may take a little while, so I'm going to pause. And we're back, and you can see that it worked. On my screen in particular, with it shrunk down like this, it's not very readable. Okay. Yeah. So yeah, but you can see X, Y, and this is creating that chart. If you run it on a larger screen or give it more area, it should look better. There it goes. It just took a minute to update. Okay. Also, you can make it look better. Fix up the names and all by grabbing this code and using this code instead. Now what we're doing, as you can see, is we're doing a lot of copying and pasting, and you will do a lot of copying and pasting of code in this class. It's just part of learning to run R and really any programming language, because R really is a programming language, and that's how I use it. So we'll pause again. And that's done. Okay, now next on the list is to go and take a look at some more 2D plots. R is pretty cool for doing plots, right? As you've already seen, you can just take data sets and you can just plot them, right? So here we can just plot X. Well, that also applies to plotting any of the data from our data frames, right? Whoop, whoop. It's taking a little while. It's got a lot of data to plot. Okay, so good warning for you is that R just crashed on me completely. Tried to kill it, tried to save what I had, and ended up killing it with Task Manager. So all the more reason to make sure you sweep periodically. This seems to impact it, especially when you get a lot of plots or a ton of data. So make sure you clean things up on a regular basis. Also, don't run off of a Google Drive. Move your data and your R scripts to your local computer. Work on them there. And R should run pretty quickly. Even with this data set with 5,000 odd points, it should not take long to run that simple plot that I was trying to run. So there's another two-dimensional plot if you just give it two variables. So in this case, my response and my independent, but they could both be independent to test and or visualize if there's correlation between them. Yeah, so you can do that. And it's very easy. Whatever you put in with separated by commas, it will try to plot. There's a whole bunch of other things in R for plotting. Some of that I put on this page in sample plots. Please change the labels in R. The default labels with the dollar signs are just not acceptable. Apologize. Okay. But there's tons you can do with R with plotting. Change the colors. Here's box plots. And then there's just a bunch of information. Whoops, have to fix that one. Quick R, great guide, especially for plotting. They have a whole bunch of different plotting things you can do. And not only that, but there's a bunch of extensions for R, things you can plug into additional libraries, which is one of the powerful things about R is all the other packages that you can install for it. And we'll play with some of those, and I'm sure you guys will find new and interesting ones as well. Okay, have fun.